Have you ever wondered why the periodic table looks the way it does, with its rows and columns filled with elements? This tableau of science, crafted meticulously over generations, is our key to deciphering the enigmatic world of chemistry. Each element, each row, each column has a story to tell, a puzzle to solve. The periodic table is not just a chart, it's a map, guiding us through the labyrinth of atomic mysteries. In today's video, we're diving deep into the elemental world of the periodic table. Starting from the left, the first two groups are known as the alkali and alkaline earth metals. Alkali metals, comprising the first group, are incredibly reactive. They're like the life of the party, always ready to mingle and form new bonds. They're soft and light, with low melting points. Ever heard of sodium? That's an alkali metal, a common ingredient in your table salt. On the other hand, we have the alkaline earth metals in the second group. They're like the alkali metals' slightly more reserved cousins. They're harder, denser, and melt at higher temperatures. They're still quite reactive, though not as much as alkali metals. Magnesium is an example here, commonly known for its role in human health and for its flammability. Both these groups share a trait: they love to react with others, especially with halogens and oxygen. So these are our first two groups, the alkali and alkaline earth metals, always ready to react. Moving right along, we encounter the transition metals. These are the middle children of the periodic table, located in groups 3 through 12. Now, what's so special about these metals? Well, let's dive in. Transition metals are known for their variable oxidation states. In simpler terms, they can lose a varying number of electrons when forming compounds. This is a significant departure from other elements that have fixed oxidation states. This ability gives transition metals a certain versatility, allowing them to form a wide range of compounds with different properties. But that's not all. These metals also have high melting points. That's right. You'd need to crank up the heat quite a bit if you want to melt one of these elements. This property makes them ideal for use in situations that require materials to withstand high temperatures. Now, you might be wondering, what's their role in the grand scheme of things? Well, transition metals are often used as catalysts, substances that speed up chemical reactions without being consumed. They're the speed demons of chemistry, if you will. They help reactions that would otherwise take ages to complete, finish in a matter of moments. So to sum it all up, transition metals are the jack of all trades of the elemental world. They can do it all: change their oxidation states, withstand high temperatures, and even speed up chemical reactions. These transition metals, they're the versatile performers of the elemental world. Beyond the transition metals, we have the metalloids and nonmetals. Stepping into the realm of metalloids, we encounter elements that are, in essence, the chameleons of the periodic table. They have the unique ability to exhibit properties of both metals and nonmetals, depending on the conditions. This group includes elements like boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. What makes these elements special is their semiconducting properties. You see, normally, metals are good conductors of electricity, while nonmetals are poor conductors. However, metalloids straddle this divide and can conduct electricity under certain conditions, but not as well as metals. This is why we often find them in the heart of our electronic devices, like computers and smartphones. Now let's navigate towards the nonmetals. These are elements that generally lack the typical metallic luster, are poor conductors of heat and electricity, and tend to be brittle if solid. They include hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. Nonmetals are vital to life as we know it. For instance, oxygen is crucial for respiration, while carbon forms the backbone of organic compounds. Interestingly, nonmetals have a wide range of states at room temperature. For instance, bromine is liquid while oxygen is a gas and carbon is solid. This variability is a testament to their diverse nature. But here's a fun fact. Did you know that nonmetals, despite being fewer in number compared to metals, actually make up a majority of the Earth's crust, oceans, and atmosphere? Carbon, nitrogen, and oxygen, all nonmetals, are some of the most abundant elements on our planet. Indeed, the world of metalloids and nonmetals is rich and varied, full of elements that challenge our typical metal versus nonmetal dichotomy. They're not just in between or other, but unique in their own right, integral to the fabric of our daily lives and the universe around us. Metalloids and nonmetals, the elements that blur the line between metals and nonmetals. Finally, at the far right, we find the halogens and noble gases. To begin, let's dive into the world of halogens. These elements, found in group 17, are voraciously reactive. Why, you ask? Well, they're just one electron short of having a full outer shell, making them eager to form bonds with other elements. They're like the social butterflies of the periodic table, always looking to make a connection. This eagerness to react makes them incredibly useful. For instance, chlorine is used to disinfect our water, while fluorine is added to toothpaste to prevent tooth decay. And iodine, it's essential for our health, helping regulate our metabolism. Halogens are not just useful, but also ubiquitous. They're found in seawater, in our bodies, even in the Earth's crust. So next time you're at the beach, remember, you're literally swimming in a sea of halogens. Now let's switch gears and talk about the noble gases. These elements, found in group 18, are the introverts of the periodic table. They've got full outer shells, which means they're perfectly happy on their own. Thank you very much. This lack of reactivity makes them incredibly stable. But don't let their aloofness fool you. Noble gases have their uses too. Helium, for instance, is used to fill balloons and airships, while neon is used in advertising signs. And argon? It's used to create an inert atmosphere for welding and in incandescent light bulbs. These gases are also found all around us. They're in the air we breathe, in the Earth's crust, even in outer space. So the next time you take a deep breath, remember, you're inhaling a bit of noble gas. From the ever-reactive halogens to the unreactive noble gases, the rightmost groups of the periodic table sure do keep things interesting. Last but not least, let's not forget the lanthanides and actinides. Nestled at the bottom of the periodic table, these two series of elements, 15 each, are often overlooked, but they certainly pack a punch. Let's dive in. The lanthanides, also known as rare earth metals, are incredibly useful. They're found in everything from cell phones to renewable energy technologies. You know those super strong magnets? Thank lanthanum and neodymium for that. Now onto the actinides. These heavyweights are all radioactive, and they include the notorious uranium and plutonium. While they might be infamous for their role in nuclear weapons, they also have peaceful applications. Uranium fuels our nuclear power plants, providing a significant portion of the world's electricity. So, while these elements may seem distant and a little intimidating, they are integral to our modern world. The lanthanides and actinides, they're the elements that add depth to our elemental exploration. So, we've journeyed through the periodic table, but what did we learn? Well, we've certainly come a long way, haven't we? Starting with the elemental enigma, we've delved into the mysteries of the periodic table, unlocking the secrets of the elements that make up the world around us. We began our adventure with the alkali and alkaline earth metals. These lively characters in the first two groups of the periodic table reminded us of the reactive nature of elements and how they're always eager to interact, bond, and form new substances. Next, we plunged into the sea of transition metals, a group teeming with a plethora of elements that are central to our lives. From iron in our blood to gold in our jewelry, these elements showed us the diverse roles they play in our world. Then we navigated the intriguing territory of metalloids and nonmetals. The elements here, straddling the boundary between metals and nonmetals, offered us a fascinating glimpse into the complexities of elemental behavior and their myriad applications in our daily lives. Our journey then took us to the vibrant world of halogens and noble gases. We learned about these groups of elements that are, in many ways, polar opposites. The reactive halogens and the aloof noble gases, each with their unique properties, highlighted the incredible variety within the periodic table. Finally, we explored the world of the often overlooked lanthanides and actinides. These elements, while less common in our everyday lives, play pivotal roles in areas like nuclear energy and advanced technology, reminding us that every element, no matter how obscure, has its place and purpose. By understanding the periodic table, we gain a deeper understanding of the elements and their behavior. It's not just about memorizing names and numbers, it's about appreciating the beauty and complexity of the elemental world. and that's the periodic table for you, a map to navigate the elemental world. Remember, every element has a story waiting to be told.